Hello again, everybody. This is Frank Hunt. Last time we were here, we were talking about the current going through this from the source through the hot leg, through the switch leg, and through the light bulb. And today we're going to continue on that and go a little more into what it means to have things in series and in parallel. And basically, we're going to touch on Ohm's law. Don't get scared now. It's only 9th grade math. You can handle it. All right. Okay. So. We have a 12-volt source. We have the path that the current flows through in the switch leg through the switch to the load, right? And this load has got to match this source. So we got to buy a light bulb that's basically manufactured to operate at 12 volts. We're going to have a 12-volt source. If we wanted to put more source, you might say, we could add another battery, which I think we touched upon a little bit the last time. If we put another battery here, we would take the second battery and connect it in what we call parallel to the first battery, so that this battery, number 2, is doing the same thing as battery number 1, and it's just more capacity. So there's all a chemical reaction going on in here, and a chemical reaction going on here, so there's more lead, there's more metal, there's more chemical reaction going on capable. So this light, basically, if it was a flashlight kind of a setup, it would just last twice as long, right? But the voltage would be the same. So now I'm going to talk a little bit about how we can predict how much current, the quantity of amps that are going to flow through here. And we need to know that information so that we can decide what size wire we're going to use and what size fuse we're going to use. If we cut this wire open, for example, and we put in here a fuse for the current to go through, we can monitor, or we can control, I should say, or limit the amount of current that's going to go through here. So if I were to buy a 1 amp fuse, then this fuse would allow 1 amp of current. That's the quantity of electrons, you might say. The quantity of current going through this fuse would be limited to 1 amp. So let's do a little math to figure out if that 1 amp fuse is adequate for this one light bulb, for this one source. 12 volt source, 12 volt light bulb, 1 amp. We need one more piece of information, and that is this light bulb manufactured with a certain amount of built-in resistance. When the current comes through this light bulb, the resistance is higher than on the wire, so the wire inside this light bulb glows and burns, literally creating visible light when this thing's on fire in here. And we can calculate how much current that's going to be when you buy this light bulb. So we buy a light bulb, we put it on the bench, for example, we hook it up to an ohm meter, and we can measure the actual resistance, how much resistance there is on that particular light bulb. So let's say we measure this resistance with an ohm meter, and we measure it to be, the resistance equals 24 ohms. That's the Greek symbol, omega, for ohms. So this is a 24 ohm light bulb that we bought. So now with that information, we can calculate how much current is going to flow before we even turn the switch on. We know what's going to happen before we turn the switch on. That's our goal as electricians. We don't turn the switch on and see if it blows up. We know what's going to happen before we turn the switch on. And we use this formula, relatively simple. E equals I times R. That's called Ohm's law. This is as simple as, I'm sure you all know this from 3rd grade, 2 times 4 equals what? 8, right? So if we have replace these letters with some numbers, we go like 8 equals some number times 4. What's the missing number? It would be 2, right? And how did you know mathematically that this number that's missing is 2? How much current is going to flow in this particular example is going to be 2, right? Because you would do a little math showing that 8 divided by 4 equals 2. So if you go back to 8 divided by 4 equals some number, which now we know is 2, right? We can change these letters back to what they were. This is E divided by R equals I. So Ohm's law is as simple as 2 times 4 equals 8. So we're going to use this formula to calculate how much current is going to flow through here. In this case, our voltage that we're using is 12 volts, right? So let's put the numbers in here. 12 volts from our source divided by the resistance of, we measured 24 ohms, right? That light bulb is a 24 ohm light bulb. So 24 ohms equals 0.5 amps. 0.5 amps is less than 1 amp, so this 1 amp fuse is going to work. Matter of fact, if we wanted to, we could put another light bulb in this circuit, and we could have another 0.5 amp light bulb burning. So going through this particular part of the circuit, we would have 0.5 amps. If we cut any place in this ohm meter, if we cut any place into this circuit and put in an amp meter, like for example, we would cut the wire here, put in an ammeter. This ammeter would show .5 amps. A half of an amp going through that wire, half an amp going through that circuit, half of an amp going through that switch when you make contact, half of an amp going to the switch leg, half of an amp going through this, and half of an amp returning back to this source, whether it's 12 volts and 12 volts. It's still 12 volts. That's a 12 volt source. So let's put another light bulb in here, just to prove the math one more time. Suppose we tie a wire on here, and we come over and we say, okay, let's put another light bulb in that circuit. We put another light bulb in. In this case, we're going to call this what it is, which is a parallel circuit. Come down here and connect. You can see the circuit. At this point, you got current can go through this light bulb, or the current can go through this light bulb. Alright? The second light bulb will be working at the exact same time as the first light bulb. Alright? We get light here. And the amount of current that's going to go through the second light bulb, because it's the same manufacturer, style, light bulb, voltage, wattage, everything. This is a 12 volt light bulb, and it happens to be 24 ohms of resistance. The current going through here from this formula is going to equal 0.5 amps. And the current going through this one is 0.5 amps. So the current going through in the total is going to be this 0.5 plus this 0.5, right? It's going to be 1 amp. So it's going to be exactly 1 amp going through that 1 amp fuse. And now this meter is going to read 1 amp. Make sense? Once you have a path that the current flows through, before we had only one light bulb, but now we have two light bulbs. Anytime you have more than one path, we have one path here and one path here, we call that a parallel connection. More than one path, that's the key to seeing that there's more than one path. It's not in series, but they're in parallel. And this is typically the way your house works. You can have the kitchen light on, or you can have the living room light on, you know. You can have one switch going to two lights. When you turn them on, they both come on at the same time. You could have one light bulb blow out, and the other light will still work. Right? Parallel connection. And this is the beginning of learning a little bit about Ohm's law. So kick that around for a little bit. Oh yeah, one more thing. The parallel connection of the source. You can see that we have more than one way for the current to flow when it gets to a connection. So we have more than one connection at the parallel source, just like we have more than one connection at the parallel load. Alright? Makes sense? Thank you. Alright. Let's see what else.